Welcome back, everyone, to Chem 102. My name is Professor El Hawari, and today we are going to be doing experiment number three. And experiment number three is physical properties, density of liquids, and their miscibility with water. We are going to be defining these terms. We talked about density, as you remember, in previous labs, and today we are going to be doing an experiment again with density of liquids and their miscibility. So the task for you, task number one, please go to Brightspace and make a copy of the lab report template. I showed you how to do this in an earlier video for the first few labs. If you have any questions, please reach out to me, make a copy, and fill in the copy of your lab report as we are going. So again, the first thing I want you to do, once you make a copy of the lab report template, please put your name and date for today's lab. And just like with every lab, we're going to start by writing an objective. So the objective should be one sentence that clearly describes the goal that you hope to accomplish for this lab and the method used. One thing you can write in your lab is our objective is to observe and determine the miscibility and relative density of various liquids when mixed with water by examining layering and position in the mixture. Again, it's to observe and determine the miscibility and relative density of various liquids when mixed with water by examining layering and position in the mixture. Pause the video, write down the objective in your lab report template. The equipments we'll be using for this lab will be using the beaker, the disposable pipette, and the stirring rod. So I want you to list the equipments on the left and list their function on the right. So we will be discussing their function one more time. So again, pause the video as we are going through the equipment and function and write it on your lab. So the first equipment is the beaker. So the beaker, which as you see right here, is a common lab container used to hold, mix, and heat liquids during experiments. Next up, we have the disposable pipette. The disposable pipette is used to transfer small volumes of liquids accurately and safely, then discarded to prevent contamination. We'll be using this today in today's experiment in order to transfer liquids to measure their miscibility in water. And the last one is the stirring rod, which is used to mix chemicals and liquids smoothly and safely in the lab. So let's define the word miscibility. So, miscibility is the ability of a liquid to mix with another liquid, and the key word is homogeneously, which means that it mixes evenly. So, you only see one layer. And let's go over some important terminology. And again, important words are highlighted for you, they're boldened. So, make sure you make a note of them. If you have only one layer, an even mixing, we call it a homogeneous mixture. And another word for homogeneous mixture is a solution. If two liquids, when you mix them, they mix and they form one homogeneous layer, we say these are miscible liquids. On the other hand, if you mix two liquids and they do not mix, we say they are immiscible. If we look at the picture on the right, we have two liquids. We have water and we have oil. Notice the two liquids are not mixing. So we say water and oil are immiscible because they do not mix. Now, if you have two liquids that are miscible, meaning they mix and form one homogeneous layer, if you pour them in the same container, they will instantly mix. So you are going to have a solution. But if the two liquids are immiscible, then you are going to start seeing different layers. And it's very important. Different layers means they do not mix because they have different attractive forces. They have different forces of attraction. The miscibility of a liquid with water is particularly important. And the reason why we care so much about water is that a lot of the experiments are water based. Even our body, it's made up of mostly water. And as we also said in a previous lesson, the earth as well is made up of mostly water. So that's why we care a lot about water. Now, many liquids are miscible with water, but as we just saw, other liquids are not, like oil will not mix with water. Let's talk about density and let's see if we can figure out a relationship between density and miscibility. So, density, actually, we discussed it in an earlier lab video in a previous experiment, and we are going to talk about it today with relations to miscibility. If you remember, we defined density to be mass divided by volume. And density can be determined experimentally, again, by measuring the mass and volume, not only for solids, but we could also do for liquids and gases. Density is so important because it allows us to identify the physical properties of specific substances. And if we look here, while we're continuing with our density notes, notice that water and oil, as we said, do not mix. And notice water is at the bottom layer, which is very important. Water being in the bottom layer means that it is actually more dense than oil. So the key summary is when a liquid is poured into water and when you see a different layer, that means both liquids have different densities. And the key piece of information we want you to know is that if the liquid is less dense than water, for example, then it will be at the top layer. It will float on water, for example, the oil. But if the liquid is more dense than water, then it will be at the bottom layer. It will sink to the bottom of the container. And if a liquid is miscible with water, then we will have a homogeneous mixture and we will see no layering. It will only be one layer. And if there's no layers, then we cannot determine which liquid is more dense and which liquid is less dense because we don't have two or more layers. So, in order to determine qualitatively which liquid is more or less dense, we need to see at least two distinct layers. So, different substances will always have different densities. All right, for the experiment again that we'll be carrying out today, we'll be using a beaker, a disposable pipette, and a stirring rod. The procedure that we are going to be following for this experiment, we are going to pour some of a liquid in a clean beaker, and then to the liquid sample, we are going to add some water now. We will have 3 tables that we are going to fill out. I'll show it to you on the next slide. Again, you will find it on your data sheet. For table 1, you are going to write if you see layering when the two liquids are mixed. And then based on that observation, we are going to write the liquid sample. Is it miscible or immiscible with water? If the liquid sample is immiscible, in table 2, we are going to write whether the sample is at the top layer or at the bottom layer. And then finally, based on that, for table 3, we are going to say if it's more dense or less dense. And then we're going to write that in our observation. And then we're going to repeat the steps for all the liquids that we are testing. So again, the materials are over here. We have ethanol, acetone, ethyl acetate, mineral oil, methylene chloride, and distilled water. We will be testing these liquids 1, 2, 3, 4, 5, these 5 liquids to see their density and miscibility with water. So let's start off by showing you the tables again, which you'll find on your lab data sheet. For table 1, you are just going to say, do you see 2 layers or no layers, miscible or immiscible. For table 2, you're going to say if you see any layering, you're going to say is it top layer or bottom layer. If you don't see any layering, you are going to write NA, which means there is no layering, not applicable. And then for table 3, after stirring, we are going to write our observation. And then we're going to write, are there any changes in miscibility for table number 3? All right, so let's start off with ethanol. Ethanol is a form of alcohol. So we will be using the pipette, adding some ethanol into the beaker. That equipment is called a beaker. We'll be taking some distilled water, which is pure water, and we'll be adding it. Now we want you to notice, do you see two layers or do you see one layer? As you can see, it is just one layer, homogeneous mixture. So for the first observation, you can say no layering. You don't see any layer. Now, if you don't, so if you only see one layer, what are we gonna conclude? Is it miscible or is it immiscible? Yes, it is miscible. Miscible means they mix. You can remember MM. Miscible means they mix. So can we figure out any density observation? So we're gonna write no layering for table 2. So we don't see any other layers. So the conclusion would be Na not applicable. So we can see that when we stir it, again, we don't see any layers, non-applicable, and finish the 3 tables. Now you can pause the video, record all your observations for table 1, 2, and 3, and now let's go on to the second liquid. The second liquid we have is acetone. Let's see how acetone behaves. All right, we're adding some acetone again in the beaker, and then we'll be adding distilled water, which is water that is pure. It has no ions. Distilled means it's pure water. Record your observation. Water is being added to acetone. Acetone is a type of ketone. All right, so as you can see, I only see one layer. So since it's one layer, you can write no layering. So we don't see any layers. It's just everything is one. So no layering, and it's miscible. Miscible means it mixes. And for the density observation, again, no layering. We only see one layer, and the conclusion would be Na. We cannot distinguish the density. We cannot know for sure the density, which one is more dense and which one is less dense. Is it acetone or is it water? Because they mix. Because they mix. So you can write Na for your density observation, and then you're going to fill out table 3 accordingly. All right, now we're up to ethyl acetate. Ethyl acetate. Now we might be wondering, is it going to be similar to water or different? So we'll be adding some ethyl acetate, closing the container, going back to our water, adding water. And I want you to notice this time. This time will be a little different. This time it's a little different. Let's stir it up. Before we can make any judgment, let's stir it up. All right, this is a little different now. Now, this actually, it was two layers. If we When we go back at the very end to show you, so ethyl acetate actually makes two layers with water. It might be hard to see because both liquids are clear, but ethyl acetate actually made two layers. So for the conclusion for table one, we're going to write it's immiscible, means they do not mix. And ethyl acetate actually formed the top layer. It was sitting on top of water. So the question that I'm going to ask you, if it's on top of water, is it more dense or is it less dense? Correct. That means it is less dense. So fill out your tables accordingly, table 1, 2, and 3, and then we'll move on to our next liquid. The next liquid we have is mineral oil. Mineral oil. It, it's a little hard to visualize again these liquids because they're all clear. So maybe this is something you might write in your conclusion. You might say it was hard to visualize because they're all clear. But notice mineral oil. Look at that. You know, it's, obviously it's different from water. It's oily. All right, we're going to be adding water now to oil, mineral oil. Okay, notice we're adding the water. The water wants to go to the bottom of the beaker. Notice the water is pushing the oil. We're going to mix it. Let's mix it so you can see it. Water is, see, two layers now, not one layer. I can see two layers. I see the water. Yeah, the water is at the bottom, and the mineral oil is at the top. The oil is a little bit more viscous. So you can write, we saw two layers. If you see two layers, that means that they are immiscible, means they do not mix, immiscible. And then for the density, since they're immiscible, you're going to write mineral oil. It was the top layer, top layer. And if it's the top layer, again, just like ethyl acetate, if it's the top layer, therefore, is it more dense or is it less dense? Correct. That means it is less dense. Less dense. And our final liquid for this experiment is methylene chloride. Methylene chloride. So I want you to note the consistency of methylene chloride. We're using the transfer pipette, also known as the dropping pipette, dropping some methylene chloride in the beaker. Feels like it looks like water, looks like it has the same consistency, but looks could be deceiving. Let's add some water and see how things behave. Notice the water is actually going to the top. It's not going to the bottom this time. If you rewind the video a little bit, you'll notice that methylene chloride, the water is staying at the top, but for mineral oil, it was going to the bottom of the beaker. So look at that. This is two layers. And if you ask, you might be wondering, I can't see the two layers that much, but if we look from the top, you can see, and from the sides, you can see bubbles. Imagine if you're adding oil to your salad dressing, your salad, that when you see bubbles, that means they're not mixing. See, we're going to go back to our previous experiment. They're not mixing the methylene, the mineral oil. And if you look at the ethyl acetate, ethyl acid again, two layers. Acetone, one layer. You don't see any bubbles. Ethanol, one layer, no bubbles. So in your observation, in your final summary, make sure to talk about the bubbles and how you were able to know for a fact or for certain that you saw more than one layer. It's because of the bubbles. So before we go to the review slide, methylene chloride, two layers, which means that it is immiscible, and methylene chloride stayed at the bottom of the beaker, so it was the bottom layer. And since it was the bottom layer, we say it is more dense. It's methylene chloride is denser than water. So now you should have all the data for tables 1, 2, and 3 to complete. Right now, for the final review slide, we are going to show you one more time the experiment. First one was ethanol, one layer. Alcohols are ethanol has water. This particular ethanol. Now we are transitioning into acetone, ketone. You see, one layer. Now ethyl acetate. You can see the two layers. You can see a bit of two layer ethyl acetate. Mineral oil, definitely two layers, because water and oil don't mix. Look at that. And ethyl acetate and methylene chloride, again, if you look, two layers. Two layers. Two layers. It's actually ethyl acetate, the middle one is quite surprising because acetates are usually, with the intermolecular forces, they usually dissolve in water. So it was when we did the experiment, it was rather interesting. All right, very important now. So make sure you're writing. So your final summary is thoughtful. Make sure it's one or more paragraphs, and you summarize the results of this experiment. Make sure you write in full sentences. Do not use bullet points or sentence fragments. Check your grammar before submitting the summary. Make sure to describe trends. Make an effort to support your statements by referring to the theory in the pre lab discussion and the theory that we discussed during the video. For instance, do all immiscible liquids float on water, or do they sink in water? Does stirring liquids improve their miscibility? These are some questions that you need to be addressing in your summary, the final summary, which you'll find on your lab report, the very last part of your lab report. Some reminders: you are expected to complete the following for each experiment. Watch the video, make sure to complete the quiz based on this video, and also do not forget to submit the lab report. You can pause, rewind segments of this video, and make sure to fill it out completely. Any questions, please let me know. Thank you and see you soon.